Hello, everyone. Thank you for joining me today. Today, we'll be going over the time estimation for manufacturing's template and how to properly fill it out. So with this video, you should be able to complete this assignment with the resources that we've provided with you. And if you have any more questions after this video, please reach out to a TA or an instructor, and we'll be more than happy to help you guys through these steps. Let's first go to the actual course webpage, and I will start sharing my screen. So as we can see here, we're on the actual design and manufacturing laboratory website. We will go under project resources. Under project resources, we will go under design report 2 concept selection under the manufacturing time and cost estimation. So with the time estimation guide for parts manufacturing and manufacturing time estimates template, you'll be able to create the proper manufacturing times and for this actual assignment. So please download both these Excel files and you'll be able to read them and understand. So with that, I'll go ahead and share my screen and we will move on to the actual time estimation for manufacturing lab parts document. When you open this document, you'll be shown the actual shaft clamp bracket. The shaft clamp bracket will sometimes be a little small on your screen, depending on what your default settings are. So you may go to the right-hand corner, increase the zoom size, and we will see that now it is at 200%, and we can actually read the actual procedures. This right here is a demonstration of the shaft clamp bracket, which is a specific part that we have typically machined in lab in person, so that this will give you guys an idea of how this actual manufacturing process sheet works. In addition, we have a beginner slot and an intermediate slot. We will talk about that a little bit later. But once we glance through these procedures, we can also see in the bottom here, there is an actual drawing of the part that is being manufactured. So these steps correspond with this actual part. So in addition to that, we have provided you guys an example for a wheel hub, a motor mount bracket, an end store wheel hub, an example sheet metal part. These are all examples and may not be the correct procedures to manufacture your part. So please just use this as a reference and examples of how these documents should be put together and how they all work. Lastly, we have an example mobile platform assembly right here, and this is an example of an assembly of all the components and off-the-shelf parts so that they all can create the mobile platform. So please also understand this example. Lastly, we have one more sheet at the end, which is the task legend. This will be the most important sheet that you guys will be needing. And this is basically an index of all of the procedures listed in these sheets prior that you guys will be able to copy and paste into the actual template and tally up the times that you need to make your actual part or assembly. However, this index will cover about 80 to 90% of the things that you'll need for your actual parts and assemblies. So if for anything that's not listed here, please either reach out to your TA or an instructor, and we will be able to give you guys those times and provide guidance. Or if you have any prior manufacturing knowledge, you'll be able to implement it here. But most of us will not have that. So please make sure to double check with the TA, and the TAs will be able to help you guys out with estimating the times for the specific procedure that you may need for your part. We can see here, we have just a list of steps and a beginner and an intermediate time slot. So before going deep and down to that, we will go ahead and move on to our example today. So today we will be going over an assembly for a mobile platform. This is the same images shown in the example mobile platform assembly in one of the prior documents that I've shown. And we'll use this as an example to walk through the proper steps that you'll need to take to create this assembly. This assembly is fairly easy, so that's why we're using it as an example today. And in addition to that, I will not be going over a specific part because it may be different for each one of your groups. So make sure that you understand that they will be different for different groups and your different parts. So for example, the wheel hub and the motor mount will be specific to your design, and those times for those actual manufactured parts will be from a parts manufacturing time estimation that you guys have made prior to this assembly. So looking at the design, we can see that there is this frame right here that is composed of 80/20. We have one caster wheel. We have two wheel assemblies with wheel hubs, and we also have a motor mount and a actual motor. Looking at this image, you can see the actual assembly of the motor mount, the actual motor hub, and the actual wheel. So we'll use these as our references for making our parts today. For your design, you will not need to make the CAD assembly or parts of your actual design. It's actually strongly discouraged so that you guys do not waste your time doing these, because your design may or may not change between now and DR3. So please just use hand sketches that you guys either have made in DR1, or you can do another simple drawing for your actual parts or assembly so that you can use this as a reference and to create your actual time estimations. You will need to provide those drawings in your actual design report, and so that you can so the TA will see what drawings you referenced and how you came up with those estimated times. So for today, I'll be using this example, and for you guys, you'll be using like a hand-drawn example. Once again, we can see here, one of the big things that we can first use to start off in our assembly process is these 80/20 pieces, because they're fairly simple and they'll need to be manufactured. So we'll go back to the actual time estimation task legend. So with this task legend, we can see that there are several steps, and two of these are going to be the mark and cut 80/20 aluminum extrusion on bandsaw and retrieve pre-cut pieces of 80/20 off the shelf. The reason why there are two processes for these is because we have a shelf that is designated for 80/20, and it has a compilation of several different sizes cut from prior semesters. This was because 80/20 is very good for prototyping, and we can constantly reuse it. The shelf is typically stocked with anything that is within half-inch increments, nominal half-inch increments. So you're going to have anything from 3 inches to 3.5 inches and so on. With that, it's going to be due to availability. So there may or may not be the pieces that you want on the shelf by the time your lab happens, because it will be somewhat of a first come, first serve due to availability and when your lab is traditionally in class. The rule of thumb that I typically like to use is that it's good to assume about half of the parts you'll be able to find off the shelf, and half of it you'll have to cut. In addition to that, you may have parts that will have a non-half-inch increment. For example, you may have something that needs to be cut to 4 1/4. The best assumption is that you will have to cut that, because that's going to be a very rare size to find off the shelf, and so that you'll be able to manufacture that part. If you have all your parts that are nominal dimensions, for example, all your parts are 4 inches and 6 inches for your 80/20, you may be able to find all of them. However, it's best to estimate the worst case scenario, which typically I find is about 50%. So for today, we'll be using two 80/20 pieces that we'll be able to mark and cut, and 2 pieces that will retrieve and pre-cut pieces off the shelf. On the right-hand side, we can see that there is a beginner and intermediate. So the reason why there's 2 columns is because for those who have never machined before, and for those who are online and may have never touched a machine before, this will be a good estimation for someone who has never really manufactured, and it's basically going to have a longer time increment to do one task. On the other hand, there is an intermediate time, which is going to be for someone who has machined before or is comfortable with machine, or has gone through the class already and at this point is comfortable with manufacturing. The option between the intermediate and beginner is just a decision that your group makes. If your group chooses to use beginner times, you all have to use the beginner time, and if you guys decide to use the intermediate, all of your group's calculation must be based off the intermediate. At some point within your design report, you will need to state which times you'll use. That's either in the just design justifications, or at the actual, or maybe a paragraph prior to the listing out your actual manufactured times. You'll state the decision that your group made. So for the beginners, you may put a justification where you state that either you're uncomfortable with the machines, or you're never manufactured with those times before and utilize those times. On the other hand, for the intermediate, you can say that either in a traditional class, we would at this point have manufactured and you would feel comfortable with machines, or you actually do have manufacturing experience, you can actually use the intermediate times. Either way, we're not going to penalize you for using which one, as long as you justify it and as long as you utilize those times consistently amongst all your estimations. So for today, I'll be using the beginner time examples. So we can see that here for the marking and cutting, we'll be using 7 minutes. And for retrieving the pre-cut 80/20, we'll be using 3 minutes. So I'll go ahead and first copy these manufacturing assembly processes, and I will move to the other sheet. Here on the other sheet, we have the individual part template and the assembly template. So the individual part template will be utilized for the motor mounts and wheel hubs or any specific parts for your design. The assembly template is what we'll be using today. On the assembly template, let's go back to the 100% view. We will see that there is a design 1 and design 2. Right here will be basically a compilation of other designs if it will fit within your print page. So that's going to vary across designs. Some assemblies or some parts may have really long manufacturing time estimates. So make sure to adjust it as appropriately. And if you can't fit 2 of them on one page, you're more than welcome to. So we're going to go ahead and zoom in. We can see here we have the time estimation for manufacturing. I have already changed the title to the mobile platform example. For this is what we'll be doing today, but make sure to change it appropriately for your design. We can see that there are these columns right here. We have the manufacturing assembly process, the estimated time, quantity, and subtotal, which is minute and hour. Right here is going to be for design 1. And there's going to be a total listed down on the bottom right of this portion of the estimation sheet. So we can, right here, I will go ahead and paste the actual procedures that we have seen in the task legend. As we recall, the marking and cutting takes 7 minutes and the retrieving takes 3 minutes. So with that, the quantity, I will specify 2 and 2 because like I said, I'll estimate probably half of my parts I'll be able to find. The other half I'll need to cut. We can see here we have a minute total. I can go ahead and utilize either a calculator and input it. However, with Excel, you can also just do the math in the actual sheet, which is what I'll be doing today. So make sure you are comfortable with Excel and so that you can utilize it to your benefit. And then lastly for here, divide by 60 to convert from minutes to hours. And here we basically have already filled out 2 steps for the actual mobile platform example. So this basically gives us the parts for the top frame of the actual assembly. And we will go back to our actual assembly and we can see that now we have cut these 4 pieces. The other parts that we'll need are the motor mounts and the wheel hubs. Everything else is pretty much off the shelf for the motor mount, for the motors, for the wheel, and the actual cast wheel. So we'll need to manufacture the motor mount and wheel hub. So with the motor mount and wheel hub, I will be using just a time that we have come up with, just a general motor hub and motor mount, not specific to this design, for an example today. For you guys, however, you guys will be coming up with that time from your actual individual part estimation template, which is right here, after you have decided on which motor mount or wheel hub you'll make. And then you'll be utilizing those times to fill out this sheet, because there's may be different holes, different dimensions, and so on and so forth. So today I'll just be using a sample time that we've come up with in past semesters. So we'll be manufacture a motor mount. And we will also manufacture a wheel hub. So for my estimation today, for my actual motor mount, I'll be estimating about 72 minutes. And for the wheel hub, it will be approximately 205 minutes. For the motor mount, for the amount of motor mounts, I'll be needing 2 for the actual mobile platform, and I'll be needing 2 wheel hubs for the actual wheel hub. With this, I can drag down the formula, and we are populating the sheet. So for the motor mount, it's pretty self-explanatory. You'll have to make 2, and that will be the amount of parts and amount of time that you spend on making those parts. However, for the wheel hub, you have to be aware that on the example sheet, we also have listed a modify wheel hub made early in the semester. That is applicable only for semesters that we have come in and actually manufactured. So for those who are online, or for those who have not manufactured a wheel hub at this point in class, you'll just calculate the individual part template, utilize your individual part template calculated time for the wheel hub, and populate 2 for the quantity. For those that have manufactured a wheel hub at this point, the wheel hub that we've created in class is basically 80% of completed with regards to a generic wheel hub, and you'll just need to modify it to the actual motor that you've chosen for driving. So as you'll see in the actual example mobile platform assembly in the other document, we have a time listed for that, so you can utilize that time. But for today, we'll just assume that we have not made anything, and that we'll be making 2 of those actual wheel hubs today. That basically wraps up the manufactured parts that we'll need for this assembly, and everything from this point on will basically be an assembly procedure. So we will go ahead and go back to the task legend. And we can move down and we can skip all these and we can get down to here and we can see attaching a motor mount, attaching a motor, the motor to the motor mount, the motor mount to the robot frame, the wheel hub to the motor, wheel to wheel hub, caster wheel to robot frame, and attaching and wiring the control box for the first time. So we will be using all these steps to basically assemble the actual mobile platform. So I will go ahead and copy it and paste this. So I'll copy these onto the other sheet. So we can see here the time's populated. So attaching the motor to the motor mount, we'll be doing 2 of those. Attaching motor mount to robot frame, also 2. Attaching the wheel hub to the motor, we'll be doing 2 of those. Attaching wheel to wheel hub, we'll also be doing 2 of those. Attaching the caster wheel to the robot frame, we'll be using 1. And attaching the wire control box for the first time, that'll also be 1. So in that compilation, we'll be able to create, we have filled out the appropriate times for the actual assembly of this mobile platform. So down here with this calculation, it is a summation of all these values. And to the right of it for the hours, it is this summation divided by 60. Just make sure that number is correct with regards to sig figs. This number may or may not match based off of the sig figs off of this column. So just make sure to check your calculations and make sure that the value that you put here either correlates to sig figs for the minutes or the sig figs for the hour summation. That basically sums up the steps that you'll need to create a mobile platform assembly. As you can see, it was fairly easy, and all the steps were basically provided in the in the task legend on the other sheet. With this, we can go back to the actual drawing, and we can see we have attached this frame together. We have added the actual caster wheel. We have attached the wheel hub to the wheels. We have attached the motor to the motor mounts. We attach the motor mounts to the actual frame, and then put the actual wheel hub assembly onto the motor mount, which basically ties in the entire design. And thus we have completed the time estimation guide for this specific part. So we'll go back and take one more look at it. We can see that we have that time summed up. And so we have the other white spaces. You can or you may delete those to accommodate for the other design. And if you don't have enough space to fit another design, make sure to be comfortable going to the next page. With regards to the next page, you can duplicate these templates on the bottom to create another assembly. And once again, utilize the task legend that we have shown you guys that I've shown you guys on the other document and utilize those time estimations. Once again, you want to go ahead and peruse through these other examples and understand the details that we're requesting for making your actual specific parts and your assemblies. And so you'll be using these two documents to create it for all your assembly times for all your designs, and making sure that you have valid justification behind all the times and estimated level of experience to create that document. Thank you guys for joining me today, and that will be all. If you have any more questions, once again, please feel free to reach out to your TAs or the instructor, and we'll be more than happy to walk you through some of these specific steps once again, or explain to you some of the specific processes that you might need, for example, drilling or reaming, whatever it may be for your specific design. Thank you.